Okay, we're going to keep working on solving exponential equations. And again, they get a little bit more complex, but manageable. Here we have 9 to an exponent times 9 to an exponent is equal to 81. Remember, the whole point is to get b to an exponent equal to b to another exponent, then set the exponents equal to each other. So on the left side, we have laws of exponents. What do you do when you multiply powers of the same base? Yeah, you add the exponents. So on the left side, we're just going to need to add n subtract 3 plus 1 minus n. On the right side, we need to rewrite 81 as 9 squared. So I took care of the right side. On the left side, since the bases now are the same, we can set the exponents equally to each other. And then we've got n subtract 2n. So 1n subtract 2n is negative n. And negative 3 plus 1 is negative 2. All right, so we're going to add 2 to both sides. Now we have negative 1n is equal to 4, which means n is equal to negative 4, and then we do our check. So negative 4 subtract 3 is negative 7, and negative 4 times negative 2 is 8. 1 subtract 8 is negative 7. 9 to the negative 7 times 9, I'm sorry, that's plus 8. So 1 plus 8 is 9. Negative 7 plus 9 is 2. So 9 squared equals 9 squared. So there you have it. All right, so now we're going to this one is kind of a lot more complex, but if you rewrite each piece so they have the same base, then you're okay. Well, 64 is not a power of 16, so you can't rewrite this as 16 something, but 64 is a power of 4, and 64 and 16 and 64 are powers of 4, and 16 and 64 are powers of 2. I believe I used 4 in this equation, so I'm going to rewrite all of these. Remember, if something's in the denominator, you rewrite it with a negative exponent when you bring it to the numerator. So this is what we did. 16 can be rewritten as 4 squared to the 2a. 1 over 64 can be rewritten as 4 to the negative cubed to this exponent. And then on the right side, 1 over 64 can be rewritten as 4 to the negative cube, a subtract 3. On the left side, you've got some distributive to do, because when you raise a power to a power, you've got to multiply. So this becomes 4 to the 4a. Negative 3 times negative 2 is 6a. Negative 3 times negative 1 is 3. All right. And on the right side, negative 3 times a is negative 3a. Negative 3 times negative 3 is positive 9. Well, now we have powers of the same base being multiplied, so we are going to need to add those exponents. So that 4a plus 6a is 10a, so 10a plus 3. Okay. These bases are the same, so I can set this phrase equal to that phrase, and 4a plus 6a is 10a, so 10a plus 3 is equal to negative 3 plus 9. I'm going to add the 3a to both sides to get rid of the a's on this side, and then subtract 3 both sides. So we have 13a is equal to 6, and then divide both sides by 13. And I think I didn't do the check on this one because I knew the video would go long, and that would take a little bit of time, but you really should each time make sure you do the check to make sure that works out. All right, that's it for this one.